Hi guys, I'm John, and today we're going to talk about the difference between Arduino Uno R3 and Arduino Leonardo. At this moment, we're going to discuss the actual microcontroller chip of both mentioned Arduino boards, including the part number and packaging, its USB controller, number of terminals or pin configuration, components of the controller board, its PCB layout, PCB quality, the memory size differences according to its flash memory, SRAM, and EEPROM. We are also going to tackle microcontroller's clock speed of both Arduino Uno R3 and Arduino Leonardo. But first, we are going to talk about the definition of a microcontroller. A microcontroller is a compact integrated circuit designed to govern a specific operation in an embedded system. A typical microcontroller includes a processor, memory, and input or output peripherals on a single chip. So now, as to our Arduino Uno R3, it is powered by 16 MHz AT-MEGA328 with 28 pins and with a part number of A000066. While on the other hand, the Arduino Leonardo has a microcontroller chip of AT-MEGA32U4. Though both of them offer same function and features, Uno is a suitable platform for early learners, and it is used for multiple purposes which can also be used as a controller with various applications. Next is the pin configuration and number of terminals. Pin configuration refers to the cross-reference between the contacts or pins, while terminals refers to the point at which a conductor from a component, a device, or a network comes to an end. So in our thorough research between our Arduino boards, Arduino Uno has pin specifications of 28 pins with 20 mA per input-output pin current in DC, where it includes 14 digital input-output pins, 6 analog output pins, and 6 pins which can be used as PWM outputs. While on the other hand, Arduino Leonardo seems to have the edge when it comes to the number of available pins, where its specs are 20 digital input-output pins, 7 analog outputs, and 7 pins that can function as PWM outputs with 14 mA per input-output pin current in DC. The next thing we are going to be tackling is other components. Both boards provide specific values of the resistors, diode, LEDs, and transistors. Also, they have both a different variety of their oscillator configurations. Down below, I'm going to provide a table that states differences on the parts of both Arduino Uno R3 and Arduino Leonardo. The next thing we are going to talk about is the board's PCB layout. This refers to the high-level engineering tool for board design featuring smart manual routing of high-speed and differential signals, advanced verification, and wide import-export capabilities. As to our boards, both uses surface mount devices with same line configurations and input-output layouts, but Leonardo's microcontroller ports are different. The next topic we are going to talk is the PCB design. PCB design gives life to the board, and this process combines component placement and routing to define electrical connectivity on a manufactured circuit board. Though both boards seems to have sleek design, but for me, Arduino Uno wins this part because due to its smaller number of pins, it offers a cleaner facade than the Leonardo, though number of pins was compensated. Both Arduino boards seemed to be stable and had a rigid soldering. As of the memory size, this refers to the capability of the Arduino to maintain, organize, and process data. So we compared the boards as to the capacity of their flash memory, SRAM, and EEPROM capacities. Both boards have same EEPROM capabilities, which means that it could retain data within a power loss with a specs of 1 kilobyte. But somehow, their SRAM, which serves as runtime memory, have a slight difference. SRAM of Arduino Uno range up to 2 kilobyte, while on the other hand, Arduino Leonardo has up to 2.5 kilobyte. Their flash memory that keeps stored data even power is off is the same with 32 kilobyte capacity, although they have a different storage input to run their bootloaders, wherein Arduino Uno R3 has 0.5 kilobyte storage usage, and for Leonardo it has 4 kilobyte storage usage. Lastly, we're going to talk about the microprocessor's clock speed, which refers to the ability of the device to complete a processing cycle and generate pulses. As of the record, both Arduino Uno R3 and Arduino Leonardo has 16 MHz of clock speed, which means they can